Numerical 4.8. Two blocks of masses 5 kg and 3 kg are suspended by the two strings as shown. Find the tension in each string. Here are the two masses. Mass 1 is of 5 kg and mass 2 is of 3 kg. Both of the masses are attached with the help of a string, and we have to find out the value of the tension in each string. Tension 1 and tension 2 in the string we have to find out. So first of all, we will write here the value of given data. Given data. Mass M1 is equals to 5 kg. Mass M2 is equals to 3 kg. We have to find the value of tension. Tension T1 and T2. For this, we will use the formula. Tension is equals to weight. Tension is equals to weight, and weight is equals to mg. So first of all, we will find out the value of tension 1, T1. So the first string carries both of the masses M1 and M2. That is why we will write here mass, two masses it carries, T1, M1 plus M2 G. The value of mass M1 5 kg, M2 3 kg, and the value of G is 10. 5 plus 3 8. 8 multiplied by 10. So the value of T1 is 80 Newton. Now we have to find out the value of T2. T2, this string carries only one mass, that is 3 kg. That is why we will write here tension is equals to weight. Weight is equals to mg. And this string carries only the one mass 3 kg. So that is why we will write the values inside it. The value of M2 is 3 and the value of G is 10. So the value of tension 2 is equals to 30 Newton. Numerical 4.9. A nut has been tightened by a force of 200 Newton using 10 centimeter long spanner. To tighten the nut, we have used a spanner, and the length of the spanner is 10 centimeter, and force which we have applied, that is 200 Newton. Now, what the length of the spanner is required to loose the same nut? So if we have to loose this nut, so what will be the length of the spanner if we apply a force of 150 Newton? So first of all, we will write here the values of given data. Given data, the value of force F1 is given, that is equals to 200 Newton. Length of the spanner to tighten the nut, that is equals to 10 centimeter. We will change the value of centimeter into meter. And force F2 is given, that is 150 Newton. We have to find here length of the spanner L2. For this, we will use the formula clockwise torque is equals to anti-clockwise torque. T1 is equals to T2. So torque 1 F1 multiplied by L1 is equals to F2 multiplied by L2. So the value of F1 is given, that is 200 Newton. L1 value is also given, that is 0.1. F2 is 150 and we have to find out the value of L2. We'll multiply 200 with the 0.1 and divide with the 150, and in this way we will find out the value of L2. So the value of L2 is 0.33 meter. To convert the value of meter into centimeter, we will multiply the answer with the 100 and it becomes equals to 13.33 centimeter. Numerical 4.10. A block of mass 10 kg is suspended at a distance of 20 centimeter. This is the block. This is suspended with a rod. A bar or the length of this bar is 1 meter. This mass is attached from center to at a distance of 20 centimeter. We will convert this value of centimeter into meter, so it will becomes equals to 0.2 meter. We have to find out the force which is required to balance it at its center of gravity by applying the force at the other end of the bar. So if mass is attached at one end of the bar, so we have to apply a force in other end of the bar to balance the mass. So in this way we have to find out here the value of force which is required to balance the bar. We'll write here the values of given data. Mass, that is equals to M is equals to 10 kilogram, which is attached from center to at a distance of 0.2 meter, and this distance is L1, and the remaining distance from center to outward L2 is equals to 0.5 meter. So length L1 is 0.2 meter and the remaining length L2 is equals to 0.5 meter. We have to find the value of force F2. So we will use the formula clockwise torque is equals to anti-clockwise torque. Clockwise torque is equals to anti-clockwise torque. T1 is equals to T2. T1 F1 multiplied by L1 is equals to F2 multiplied by L2. L1 is equals to 0.2 meter and the value of F1 force F1, here the value of mass is given, so we will write here force F1 is equals to mg. The value of m is 10 and the mass is also 10, so it is equals to 100 Newton. 100 multiplied by 0.2. The value of F2, we have to find out F2 value, and L2 is 0.5 5. That is why we will write F2 as it is, because we have to find this value F2 multiplied with the 0.5. 100 multiplied with the 0.2 divided with the 0.5. This way we will find out the value of F2, and this is equals to 40 Newton.